I made I made a video on PCA. What is that? See, we don't even know the name of this thing. Okay, whatever it was. So we solved this problem, that basic, right? So you have this 2 6 2 6 and 1 7 component analysis. Which component? Principal component analysis. So here how to solve this thing I have already explained. So we'll call this as x1 and this as x2. Now we will combine both of them and that becomes x. Okay, I'll just show you the shortest way how to do it. Now you have to calculate the mean. How to do? Add this two value, okay, and add this value divided by 2. So 2 plus 1 by 2, 6 plus 7 by 2 is equals to 1.5. 6.5 is your m or mu. Both are same. Okay, got the mu. Now covariance, you have, see, there are two features. So your n value is equals to 2. Covariance, what's the formula? Covariance equals to 1 divided by n. So 1 divided by n minus 1 into what to say, x center into x center. Now what is this x center? X center is nothing but this is your x, right? This minus x minus m is nothing but your x center. How will do that? 2 6 1 7 minus 1.5 6.5. So this value will be separated for both this value. So it will be 2 minus 1.5, 1 minus 1 minus 1.5, 6 minus 6.5, 7 minus 6.5. You will get values like 0.5 minus 0.5 minus 0.5, 0.5. Now what you have to do? 1 divided by n minus 1, this into this again. So what will be? N is 2, 2 minus 1 is 1. So 1 by 2 minus 1, which is nothing but 1 again. You have to multiply this 2 times. If you multiply that 2 times, see here I have written over here, you will get, see, this row, I mean this row with this column, this row with this column, then second row first column, second row second column. You will get these values. At the end what you will get? You will get the same thing itself, which is nothing but what is that? X cof is equals to 0.5 minus 0.5 minus 0.5 0.5. Okay, the calculation part is here, which you can just pause and check it out. And then what's the next step? You have to find the eigenvalues. How will you find the eigenvalues? You have to multiply this thing with identity matrix 1 0 0 1. Okay, so how you will do that? So see, multiplication, sorry, you will subtract that. So again I'll just write it down, 0.5. I'll write this as it is, minus 0.5 as it is, 0.5 minus 0.5. okay, then you have to subtract, see, lambda into identity matrix, lambda into 1 0 0 1. You just have to multiply. So lambda into 1 is lambda, lambda into 0 0 into 0 0 into 1 is lambda again. Okay, you have to take the mod of this thing, which is equals to 0, which basically will say it's directly that this equation equals to 0. Now if you, what you have to do, subtract 0. See, this value will subtract it from this value will subtract it from this. If you can see here, see here, I've written here 0.5 minus lambda, 0.5 minus lambda. Now you will do both this, cross multiply it. Once you do the cross multiplication, what will you get? You will get, see, 0.5 minus lambda the whole square minus 0.5 whole square. Now once you open the square, see, I wrote a square minus a square plus b square minus 2ab. So 0.5 square plus lambda square minus 2 into 0.5 into lambda. Okay, so you will get this value. You already have minus 0.5 whole square, so plus 0.5 minus 0.5 square will get cancelled. You have lambda square, 2 into 0.5, 2 into 0.5 is equals to 1. 1 into lambda is lambda, so I have lambda square minus lambda, which is equals to 0. Now what am I doing? Taking lambda as common, you will get lambda in the bracket lambda minus 1, which is equal to 0. So now two things I am doing. One, I am sending this lambda to the denominator, which becomes 0. So I will get lambda minus 1 is equals to 0. So here I can do lambda is equal, so I will send this minus 1 over here plus 1. Another thing what I can do, I can send this whole thing directly here, which I will get lambda is equal to 0. So what I got two values, the eigen values, either 0 or 1. Now I have to find eigenvector. How I have to find eigenvector? There will be two eigenvector because you have two eigenvalues. So eigenvalue 1, I will take lambda is equals to 0 and I will take lambda is equals to 1. How will you find that? Same, where is this? I did here, right? Now I will substitute the value, but additionally, see, lambda into identity matrix. Now additionally, I will multiply this whole thing with one vector v. One vector. So we don't know the values, so we are just keeping as v. So how it will happen? 0.5 minus 0.5 minus 0.5 0.5, see, into 0. If we are multiplying with 0, whole identity matrix will become, so see here, x into v vector, because 0 into identity matrix is whole 0, right? So I'll have only this thing into, what to say, v1 and v2. But if we are considering at 1, we will have 0.5 minus 0.5 minus 0.5 and 0.5. Then I'll have, see here, if I'll just okay, fine, I'll write it over here, 1 0 0 1. We have the identity matrix and we have this matrix, right? This will be subtracted from this, so 0.5 minus 1 will happen. If I show, see here, 0.5 minus 1, see, this minus this minus, so 0 is 0, so 0.5 minus 0 is nothing, right? Since it is 2 cross 2, so each individual place will be subtracted to this particular place, first, second, third, like that. So this both will become minus here into v1 and v2. Do the normal multiplication. I'll show it to you over here. See, this is for lambda is equals to 1. If you do normal multiplication, you will get the values like this, 0.5. You will get one equations, both the space, two equation. Take any one equation. If you solve that equation, I'll write the equation which you will get over here. I just pause and wrote it. The equation which you will get, you will get two equations. You have to consider one. So I have considered this. So here, what I will be doing, I will send this 0 minus 0.5 that side. So I'll have 0.5 v1 is equals to, what to say, 0.5 v2 plus. If I subtract this, I'll get minus v1 is equals to v2. If I write v1 by v2 is equals to minus 1 by 1. Okay, so I can say that my eigenvector when eigenvalue is 1 is equals to minus 1 1. Similarly, if I do for this, 0.5 v1 is equals to, I'll send this here, positive 0.5 v2, cancel. So v1 is equals to v2, then v1 by v2 is equals to 1 by 1. So you can say my eigen vector when eigen is 0, it is nothing but 1 1. Okay, we completed this. Now what we will do, we will, that was visible, right? Thank God. We got both the vectors, we will combine them. So we have minus 1 1 1 1. Okay, I kept this first and this second. So I took lambda 1 plus lambda equals to 0, lambda equal, I took like that. So I will say call this as A. Now I have to perform normalization as what E. You can do two things. You can either perform the normalization for first this one and then for this one. I'll write the equation. So you'll be having x1 divided by x1 square plus x2 the whole square, but it's on the root. Then here x2 same way, x1 plus x2. Okay, like this. So if I take for here minus 1 divided by minus 1 whole square is 1 plus 1 root, so it will be minus 1. So I'll just directly write it. So finally, if you can see, you will get it as minus 1 by root 2, 1 by root 2, 1 by root 2, 1 by root 2. the only place here minus like that. So what is this? Your En, sorry, that this matrix. So now we have transformed this A into this. So now we have to find y. Like this, it's a normalization. A after normalization. Now we have to find y. What is y? Y is equals to A into x center. What is x center matrix? You already have here, right? Oh, let me just make it straight. Why am I keeping cross? So here see x center you already have as 0.5 minus, yeah? You have to multiply that. Okay, so see here you will have like this, y is equals to x center, like that. Then once you do that, you will have to multiply, and what you will get final answer? Minus 1 by root 2. Here also minus 1 by sorry, here it will be plus, sorry, minus will be only one place, but this below values will become 0. This matrix y is equals to this. I am skipping the what to say, solving calculation part. Now we got y as this. Now we have to verify that PCA actually works. So we will do that reverse thing. X is equals to A transpose into y plus m. What is m? Mean. So A transpose is what? You just have to interchange the rows and column. Even if you do so, it will be same. Then this into this minus mean. Sorry. So see here, A transpose into y matrix plus oh my bad, plus mean. If you do at the end, I'll show you what is the A into y. So A into y, I'll get half. See, it's like very basic, right? So first row into this. So the second value will be always be 0. So only one value will get. So it's basically this into this, this into this, then this into this into that, like that. So you will get half minus half minus half. You will get like this. So if you want to write or you can say 0.5 minus 0.5 minus 0.5 and 0.5. So the matrix which you got from A transpose into y is like this. Now what I have to add? Mean. Okay, that is 1.5 and 6.5. 1.5 plus 0.5 is 2. 1.5 minus 0.5 is 1. Minus 0.5 plus 6.5 is like just 6. And then adding 0.5 to 6.5 is 7. So you got the x matrix. This is the x. So it proves everything. Oh, nothing much was there. So that's the shortest form, like easy to understand what all you have to do. If I have to write, first you will assign it as x1, x2. Then you will calculate the x matrix, and then you have to calculate x center, which is nothing but x minus mean. See, x minus mean. Then you have to find x covariance 1 divided by n minus 1 into x center. Once you find the covariance, you have to find the eigenvalues. Then you have to find eigenvalue. How will you do that? Multiply this x center of this matrix into minus lambda into I is equals to 0. Same thing, lambda into here. Once you find the values, into this is equals to 0. You will get the eigenvectors. Then you have to do normalization. A is equals to, you will add both the vectors. Then what you will do, you have to find normalization of A, that En is equals to x1 then here x2 divided by x1 square plus x2 square root x1 square plus, oh sorry, my bad, x2 square root. See, x center, x covariance, eigen values, eigen vector, both the vectors have to take normalization. Once you do this, you have to find y. What is y? Y is simple. Y is equals to this A matrix into x center matrix, and then you have to do reversing. X is equals to A transpose into y plus mean. All these steps completes the problem.